Now we start to move into a slightly different realm because this is our first remote speaker. I now have the pleasure of introducing Dr. Heather White, who is an Associate Professor at the University of Wisconsin-Madison in the area of dairy cattle nutritional physiology. Heather's research program focuses on health and nutrition of dairy cows during the transition period and is centred on hepatic and whole animal nutrient partitioning and metabolism. Notably, Dr. Heather's research strives to determine the mechanism of nutrient partitioning, feed efficiency, metabolic health in order to provide science-based solutions and interventions to improve dairy cow health and productivity. Heather is hands-on researcher, mentor and instructor at both the graduate and undergraduate level. Additionally, Heather is serving as the faculty director of the Dairy Innovation Hub. So Heather will be joining the dots, connecting data streams to support whole lactation management. So I'm looking forward to welcome you here today, Heather. There's 150 people in the room and quite a considerable joining us, so welcome.
Thank you for that introduction and the opportunity to join. About a year and a half ago, I was given the opportunity to come to Australia for 10 days, and it is by far, hands down, my favorite trip I have made. I wish I was there with you in person in Bendigo, but appreciate the opportunity that technology gives us so that I can travel to the future, as it's Tuesday evening in Wisconsin, and I'm joining you on Wednesday morning to share some of our research. So I also appreciate the stage that Simone set for us. I think she did a wonderful job of putting in perspective what data can mean and the different perspectives, different contexts we can come at that from. So for me, that context is maybe a little different than some of you in the room, in that I've not, by training, a bioinformatics researcher or a geneticist. I'm simply a nutritional physiologist that loves the data that comes with some of the research that we've done. So most of my work has focused on improving metabolic health through nutritional interventions and also in understanding individual animal variants in metabolic success and in feed efficiency, trying to capture what makes each individual animal different, unique, better, and how do we harness that to implement that across the herd. As a part of that, we study the metabolic challenges, specifically those associated with the transition to lactation period and how that carries over further into that. But one thing that I've been interested in for several years now is how we might use our understanding of the biology and the underlying nutritional physiology to fuel developing, validating, identifying biological-based markers or biomarkers for predicting things that relate to cow health and physiology, especially when these predictions would yield tools that we can use on farm that are less labor intensive and less costly. Much of my work started by using milk data, especially as we gained the ability to do milk spectra analysis and look at milk or FTIR predicted milk ketones and milk fatty acids. So the area that I entered into this scene, if you will, or into this first foray of data-based predictions was by studying subclinical ketosis or hyperketonemia in the postpartum period. So as many of you know, hyperketonemia, it defined as elevated blood ketones, has a lot of negative impacts associated with it, including increased risk of displaced abomasum, decreased milk production, increased risk of culling, and decreased reproductive performance. We know that intensive detection protocols are important for early detection or identification and treatment, and those mitigate some of the negative impacts, but they're expensive and laborious. So while today's talk is not focused on the biology behind ketosis, one of the things that we did early on that has really led into my interest in this area is the development of less intensive monitoring tools for ketosis. And the passion that was created from that developing these tools to monitor health, energy balance, and feed efficiency can provide a lot of value on farm. So when we started this work, we set out to develop a prediction that instead of using these blood ketone meters that many of us are familiar with, we would instead use milk analysis and data that's routinely exported from farm management software as a part of routine monthly test. So those might include milk acetone, VHB, milk protein, fat to protein ratio, other components, alongside data from the cow management software, such as lactation, dry period length, gestation length, day in milk, and that we could integrate these together to maximize that routine milk test in a way to yield a prediction model that could provide useful information about, in this case, subclinical ketosis postpartum. And we were successful with doing that at a herd level. Shown here schematically, this is a series of privately owned farms that we worked with, Holstein and Jersey cows, where we predicted the herd level prevalence of hyperketonemia. And the actual prevalence is in the blue bar, the gold bar representing what we predicted with our earliest models. And if we use the cutoff of a goal of 10% alarm prevalence, if you will, or a goal prevalence, then you can see in most of these cases, we could correctly identify herds that were above or below this prevalence. So this work suggested that we could, in fact, make predictions that could be incorporated into something routine. And here, these models are offered to producers as a monthly report that's an integrated aspect that doesn't take additional effort from the farm in order to achieve that. So very integrated, very streamlined. Having an indicator of monthly prevalence can be a valuable management tool. And we also found that it could be used to identify risk factors on a per farm basis. If prevalence of subclinical ketosis is high on your farm, what might be the factors that are influencing that? Is it increased stage dry, or is there something else that's really increasing risk on a farm-specific level? But we lacked the ability to detect subclinical ketosis in individual cows. And there were three real concerns that remained to get us there. The first one is that the models weren't sensitive enough for individual cow detection. Next is that monthly testing only catches about half of the cows during their at-risk period. So if we think about a cow that freshens in and a monthly test would hit every 4 weeks, we're only catching that 15-day high-risk window for about half of the cows. And even those that are caught by a herd test or a routine test are only getting checked once. And we know that based on the average days of subclinical ketosis and natural resolution of that we can miss cows if we do not repeatedly sample them. So we set out to continue down this road to improve these models. And at this point, we were able to get some federal funding to increase the project. Ultimately, we ended up having more than this original 1,000 cows, but we had about 1,000 cows from privately owned dairies. And importantly, we had 4 samples per cow, so repeated sampling so that we ensured we correctly identified cows as either hyperketonemic or as non-hyperketonemic. And within this data set, we had the blood measurement for blood ketones or blood BHB, and then we also had a milk sample. And we had 2 primary objectives. One was, like I said, to improve those prediction models. So to use all the available data. In this case, we also included the raw infrared milk spectra data, and to use advanced statistical methods to predict individual cow blood BHB, and then also to identify genomic factors associated with subclinical ketosis. So I won't go through all of these models. The important part is here at the top. We were able to develop and validate an artificial neural network model that predicted individual cow subclinical ketosis with 81% specificity and 83% sensitivity. Now, a lot of us are familiar with the reference of 90% being the diagnostic goal for any test that we use, whether it's an enzymatic test or a cow-side test. And these aren't quite 90%, but we didn't have to touch the cow. We didn't go out and collect a blood sample. We weren't in the fresh pen twice a week. And so there may be some value in these compromise type prediction models. So they're certainly not as sensitive and specific as blood-based diagnostics or as calcite enzymatic meters, but the moderately lower diagnostic standards may be merited due to the convenience and the cost effectiveness. For ketosis, compared to other disorders that we might think about, the cost of over-treating subclinical ketosis is minimal, especially if we're using propylene glycol, which is by many the recommended treatment, compared to the benefit of treating an HYK positive cow versus over-treating a cow that doesn't have subclinical ketosis. So based on this, we could optimize models in favor of sensitivity, and we've even had preliminary discussions that we may be able to optimize models on a farm-specific basis. But what about our other two nagging concerns that limited our ability to use this on an individual cow basis? Cows are still only being caught, about half of cows are still only being caught postpartum, and we're still only testing each cow once. And that's when we began to wonder if we have to do things the way that we've always done them. Is there an opportunity to rethink how we do something like dairy herd improvement testing? What if instead of the traditional sample every 4 weeks, sampling all cows, what if we focus on sampling fresh cows weekly, still testing the whole herd monthly or maybe a subset monthly? And what if then from that weekly test, we got a suspected hyperketonemic cow list in return? And farms could either treat based on that list or could follow up with blood-based diagnostics. And what if you also got information about somatic cell or differential somatic cell, something that we've been working with more recently related to those fresh cows, and you could identify cases of mastitis even earlier? And if you're already doing a milk sampling weekly, what if you considered sampling other cows in the herd at the same time and you could implement a milk-based pregnancy test or any of the other milk-based tools that might be of interest to the farm? And if you integrate all these reports with feedback from other on-farm tools into a management tool, does it make the day-to-day decision-making and the long-term strategic decisions easier to implement on farm? Now, going back to the other objective of that project, we also wanted to know if we could combine this type of testing with identified genomic risk factors to further tailor the approach. Our goal here was not necessarily to change our selection habits genetically, but rather, if we could identify a risk factor, can we make a flag list so that we know which cows to really focus on with testing? So teaming up with a colleague and collaborator, Kent Weigel here at UW-Madison, he was the geneticist on this collaborative project. We looked through that same data set of more than 1,000 cows, and we were looking at pedigree-based analysis and found heritability estimates ranging from 0.071 to 0.093 in our work, consistent with other work. But the most interesting things we pulled out of this data set was because of the intensity of our sampling, having a confirmed multiple blood sample to know all cows that were ketotic or were not ketotic, we were able to identify some SNPs that were associated with genomic risk for subclinical ketosis. And so we're looking now at how we might integrate that into our, or with our milk testing programs. So if we have the ability to test cows on a more routine basis and farms are integrating that into their routine monthly testing, it suffices it to say that this generates a lot of data. And we wondered if we could use this epidemiological type data to identify risk factors for and better understand the impact of hyperketonemia. And we're working through a pretty large data set now. We've got 240,000 lactations over more than 300 farms in the Midwest region of the US, with a prevalence of 16% subclinical ketosis. We're getting ready to submit this manuscript now. Some things are similar to what we already knew and are in the literature, Like the panel here on the left, where somatic cell is greater in cows that are predicted to have subclinical ketosis. And on the right here, where previous dry period length is greater for cows that subsequently develop subclinical ketosis. And so those associations are things that we have found in the past. The dry period length one is of specific interest because it may not be a direct impact of days dry per se, but rather a reflection that those cows have a longer period of time to accrete more body condition. This is a data set of several hundred cows where we were able to follow the body condition score from 28 days prior to calving to 18 days after calving. This is a subset of that larger data set I showed you earlier. And what we found is that it's the change in body condition score across the transition period that's most important related to subclinical ketosis. So on the far left are cows that lost one or more body condition score unit, all the way in quarter point increments to the right, cows that actually gained a quarter point of body condition across the transition period. And cows that lost one or more body condition score had a greater incidence of subclinical ketosis, with over half of them developing hyperketonemia. So what's the relationship between body condition score change and subclinical ketosis? Well, in relation to metabolic disorders, it has to do with the liver's capacity for fatty acid metabolism, but we won't go into that this morning. In a broader sense or more general sense, body fat accretion and subsequent mobilization reflects energy balance. So this is something a lot of us think about on a routine basis. And you might be wondering if this goes beyond postpartum metabolic health. It could potentially influence lactational energy balance or nutrient use through lactation. It was around this time that I got involved on our campus with our feed efficiency projects that were a part of a multi-institution feed efficiency effort. This has snowballed for me. I'm now a part of both a national and an international collaboration to improve genetic selection for feed efficiency. And so at this point, when I was getting into it, you start very simply, right? Feed efficiency is a simple thing. Cows eat an amount of feed and they produce a volume of milk. And so one metric we can use for feed efficiency is residual feed intake, which is the difference between what she eats and what we predict she should eat. So if we look here at this very simplified cartoon, the dotted line is the line of unity, where she eats exactly what we predict she should to produce the amount of milk that she's making. And most of the time we put this milk on an energy basis. So a cow, these dots that are below the line, would represent a negative RFI, or a feed efficient cow, whereas the dots above the line are a positive RFI and are a less efficient cow. But things are rarely as simple as they seem, as we all know. Feed has an energetic and a nutrient value. Nutrient partitioning can be altered, which influences metabolic health and efficiency, which is the unique area that I bring to our feed efficiency projects. And energy and milk precursors can come from mobilized fat tissue, whether that's fat or protein, and may not necessarily be accounted for in these equations. So the analogy I like to use is that if you're sitting at those tables, I have a very small square where I can see little people sitting at tables here. If you eat the person sitting next to you's donut, then you gain those calories without those being held against you. Now, because of COVID, I'm pretty sure they've all told you not to share food, so please don't do that. But you understand that we have to account for all energy, even if we don't know that she gained it. One way is if she steals feed, but the other way is if she mobilizes it from stores, whether that's adipose or protein, and she uses it later. So just as I said, it's not actually a simple thing. This is what residual feed intake looks like in a realistic sense, where we have a cloud of animals that are both more efficient and less efficient. And regardless of their efficiency, they make a range of milk energy output. So we want efficient animals that are high producing and are healthy. And that last part is a key of the first part, or the first collaborative project I did in this realm. We wanted to look at if feed efficiency could be influenced by mobilized adipose tissue. Basically, if she could steal some of that energy unnoted from her own stores, would that influence her subsequent RFI or feed efficiency? And we found that there was not a relationship there between the two, which is good because it means as we select for feed efficient cows, we're not also selecting for metabolic disasters. We just recently finished a project where we looked at subclinical ketosis within a current lactation and if that influenced her feed efficiency or specifically her RFI within the same lactation. And a plot of that's here in the bottom, where the red cows are the cows that were subclinically ketotic. And you can see as they went through their lactation, there was no influence of that metabolic challenge on her subsequent RFI. We did that for any other health event as well, and there was no relationship there. So all of that's really encouraging that we can select for both feed efficient cows that are also metabolically healthy. And both of these, feed efficiency and metabolic health, reflect energy use, whether it's consumed energy or stored energy. And so we wanted to test our skills here a little and see if we could apply our approach to predicting subclinical ketosis to the challenge of predicting feed efficiency. And the first step in doing that is to predict feed intake. So there are a lot of groups around the world that are interested in doing that. And the main motivating reason is that in order to improve our genetic selection for feed efficiency, we have to have a phenotype. So you may have heard talks on feed efficiency before, where it's a hallmark that we have a geneticist and a nutritionist, and we're always working together on these projects. And it's collection of the individual animal feed intake related to our energy output. That is what we term the phenotype. And our limitation on this type of research is how many of those phenotypes we can collect a year. And they require facilities that allow us to measure feed intake. If we can predict feed intake with less invasive or less capital equipment, less stringent research conditions, then we would be able to include nearly all cows that are genotyped within our feed efficiency research. So it would change our scale from thousands of cows a year to hundreds of thousands of cows a year, which would be quite an impressive improvement. So for us, we started with predicting dry matter intake. On the top panel here is prediction of intake using 6 weeks of data. And we were able to predict feed intake pretty well, explaining 90% of variance using multiple linear regression, which performed as well as more advanced statistical approaches. On the bottom panel is if we only use any 1 week of that data. And impressively, 1 week of data performed nearly as well as 6 weeks of data, which is good for obvious decreases in labor input reasons. Cow and milk variables were the key here. Now, we also tried to predict residual feed intake, which is a little bit of a misnomer because residual feed intake, you'll remember, is the error in our ability to predict how much she would eat. So we're trying to predict error, which is a little bit circular. But the goal here is that if we can identify more of the contributions, then we can eventually be better at predicting it. So although our predictions for RFI were not sufficient, when we added sensor-derived behavior data, in this study we used the SmartBow system, it provided some valuable insights into what some of those other energy sinks might be. So what are the take-home messages here? I showed you a few different things we've been working on. All of them integrate around this energy metabolism and how we can use the biology to fuel our development of prediction models. The first one is prediction-based diagnostics may allow for improved management and detection systems that are lower input at the farm level. For us, most of our efforts have been focused on ketosis, but we've been doing a lot lately looking at other disorders and differential somatic cell and inflammation. So I think there's a lot of exciting work from our labs to come, and then also from other labs around the world. Broad implementation of prediction-based diagnostics can allow for generation of epidemiological type data. And the value in this is that it lets us learn more about the risk factors that contribute or the outcomes associated with something in real world data. So research data is great, but when we can get data from farms and then send it back to the end user, that's really useful and helpful. Having more precise phenotypes may uncover novel genomic risk factors or pathways of interest, and integration of these could add to comprehensive tools. In our work, this has been the case for both ketosis and for feed efficiency. And then the last one is our current efforts to develop predictions for dry matter intake or residual feed intake may be a valuable tool both to expand research in feed efficiency realm, but also as on-farm tools for management for farms that need to have the flexibility or the information to group cows differently, to have different nutritional interventions or programs for cows based on dry matter intake, as well as those farms that may be looking at proactively culling or managing for feed efficiency. So for that, I'd like to thank the students in the lab. Certainly they're the boots on the ground that get a lot of this research done, collaborators and funding sources. I'd like to thank the sponsors again, or organizers again, for the invitation to speak today, and would be happy to take any questions.
Now, if there are any questions, I'm just nothing on Slido at the moment. Nobody's rushed to a microphone. If there's anything, I think there's a few things. The good part is, Heather, that the presentation came through loud and clear, and it was extremely good, in depth. Just as probably a question, one of the things that struck me is that weekly testing is so translating what the work you're doing out of a research-based circumstance into a more commercial application, and is that something that's been undertaken in the States at this stage to try and expand the work, or it's still, how's that coming together for the team?
Yeah, so sorry, I was just chuckling because I can see the projection of myself on the screen there by you. And I'm pretty sure myself on that screen is bigger than myself in real life, so I apologize. But yeah, it's a great idea, because when we first broached this, we thought, is it even attainable? Is it even something that is able to be implemented on farm? And we went through a few versions. We had a couple of farms that worked with us closely, which was a great advantage, and we called them our beta testers. And really, we were trying to see what would it take to make it feasible. Is it that we have to have a trained sample collector come out from the DHI lab? Is it that you can put one of your people in to take milk samples? And we actually had one of our farms that beta tested it do it both ways. And the benefit of it to the farm was that if they tested on a Monday, by Tuesday afternoon, they would have a list of cows predicted subclinical ketotic or not, and then also somatic cell, differential somatic cell. And so there are a handful of farms that are still doing this. It's certainly not widely accepted. It's also not a broad available option yet. So it's something that we're working through still.
Okay, thanks. Now I have a question at the back. Could anyone that does get up, could you just your name and organisation pre-question? So I do know it's Matt, so I'll hand over to you, Matt.
Thanks, Graham. Thanks, Heather, for a great presentation. It's good to see you again, even though you are rather large on the screen. I was just wondering, so with the research you're doing and your testing in the field, could you describe for me, how do you actually see this implemented in a wide sense? So how do you start to use this on farm in a much broader population than your test farms? What's it look like from, say, a DHI point of view, a herd test point of view, and how does that interact with some of the work that you do in nutrition? Because I think they're intricately linked in this space.
Yeah, thanks, Matt. Good to see you too, and thanks for the great question. So I think this is where we have to think broader than any one lab, and we also have to get some folks from computer science involved. So at UW-Madison, we have a project called the Dairy Brain, where we're trying to integrate many data streams into a tool that can help make management decisions or help support management decisions. And so within that project, for example, we would stream in dairy herd improvement milk test data. We would stream in the genotype from whatever that provider is. We would stream in weather station data, and then also data from the farm level. Some of that would be feed offered, feed intake on a pin level. Some of it would be rolling herd average data to put that farm stratified against other farms within the region and integrate all that data together. So the goal of that project is to pull all these streams together. And you can imagine, and maybe some of you in the room have tried this, it's very difficult, especially with things that are proprietary, are protected, are not original data sources. And so I know that there's a lot of companies that are also trying to do this. And I think that's our next big hurdle, is how do we integrate all of this into a management software? Because if we ask every farm to take their milk test data and their genetic information and their feed supervisor data of how much they fed each pen and their weather station data and look at it, the biggest feedback we get from farms is that it's 100 windows open on their computer. They're all telling them different things and they have to take it into context. Rumination software, feed software, all of this together. And so I think our next big hurdle is, one, putting it all on the same basis so that if you're using FOSS or Delta or Bentley, all of our data is coming in and we can apply research tools across it. And then the second one is to integrate it with all of the other data streams. And so it's a manageable amount of data and a manageable decision-making tool.
Also on Slido, we have a couple of questions. One from Jenny Price. What are your thoughts on the potential for inline MIR so we could get risk of ketosis every milking, or is weekly enough? And by the way, a lovely presentation. Thank you, Jenny.
Thank you, Jenny. So this is a good question. I have not worked directly with inline MIR in my research, only because I haven't had access to a farm that has it that we could work with. I think it's a brilliant idea as far as having feedback on a routine basis, especially if we can make it manageable so that you get the data in a way that you're easily able to identify it. And so what I mean by that is rumination data is probably another good example. If you're just looking at all of the random points, it may not be of much value, but if there are thresholds, especially which can be trained for your farm, there could be a lot of value there. The one thing I would add, Jenny, is that across the literature, my work and many others, the FTIR predicted BHB and acetone are not as good of a diagnostic, they're not as robust as when we integrate it with cow level data into these more comprehensive models like I showed at the beginning of the talk. In that regard, we have to be cautious because milk BHB is not as sensitive as one of those more comprehensive models. So I think as long as we acknowledge that and we keep it in mind, we can still use it as a part of an integrated tool.
Thank you, Heather. And Jenny obviously is an inquiring mind. Can you expand on behaviours you're picking up in your sensors for DMI?
Yeah, so that's a good question. There's a lot of sensors out there. In the study that I showed, we used the SmartBow system. So we had time at the feed bunk, which is not necessarily time actively eating. It's time in a region that's defined as the area around the feed alley. And then we also had rumination and we had lying time. And so those were of varying contributions to the different models. That sensor also provides active time and highly active time, which came into those models as well. So I think that there's some valuable insight there. They didn't significantly improve the dry matter intake models, which is interesting to note in and of itself. But they did provide an improvement in the RFI models, which may give us really valuable insight in how to improve our predictions for those.
Okay, thanks. From Nicholas Lyons, any thoughts of including behavioural sensors, activity, rumination, standing, lying, or other measurements, weight, body condition score to improve predictions?
Yeah, thanks for the question. So I mentioned some of those just now. What I would add to that is that the prediction models would likely need to be specific for the source of that sensor data. In other words, we may need to have prediction models that are specific to each of those manufacturers because there are some differences in what each of them call rumination or lying or active time. And just like with a lot of things, some of those are proprietary, so we may not be able to correct or normalize. The other measurements here are really interesting. Weight was probably the most influential factor in our dry matter intake predictions, metabolic body weight specifically. And so if we're thinking about on-farm capital equipment type investments, a body weight scale is a pretty low input investment that might yield the biggest benefit.
Okay, and last question from Dennis Brooks. Would a specific cow group be more appropriate / value for more regular HYK testing, i.e. cows up to 50, 80 days in milk, rather than the whole herd? And thanks for the presentation.
Yeah, thanks, Dennis. This is a good question. We focus on cows that are within the first 20 days, 21 days after calving for the ketosis measurements. So that data comes back to the farm relative to their herd, but only the fresh cows data are run through the ketosis prediction models.
Okay, thank you. Unfortunately, we still do have some questions, and I apologise to the people who've done, but we are now at the end of our time. So once again, I'd like everyone to thank Heather for her contribution today.
Thank you.
Thank you, Heather.